So before we can even think about building a new idea, we have to look at where the old one is falling apart. And believe me, our current picture of gravity, for all its successes, is starting to show some serious cracks. So let's play detective and look at the clues that tell us something really big is missing from the picture.
Okay, there are three massive problems we need to talk about. First, gravity is just bizarrely weak. I mean, think about it. A tiny little refrigerator magnet can defy the gravitational pull of the entire planet Earth. How is that possible? Second, you've got black holes, where Einstein's beautiful equations just break. They literally spit out nonsense infinities. And maybe the biggest issue of all? Our two pillars of modern physics, general relativity and quantum mechanics, they can't even agree on what mass is. These aren't just little glitches. These are giant red flags waving at us, telling us our understanding is broken.
We've all seen this a million times, right? The bowling ball on a trampoline, showing how planets bend space-time. Well, it's time to take that analogy and just throw it out. Seriously, not only is it a circular argument, it uses gravity to explain gravity, but it also points us in completely the wrong direction for where the real action is happening.
So here's the crucial shift, the thing that changes everything. Einstein's real discovery wasn't so much about warped space, it was about warped time. An object that's falling isn't being pulled, it's actually traveling in the straightest possible line through space-time. The catch is that the flow of time itself is different in different places, creating a kind of current that guides its path.
And get this, here, near the surface of the Earth, time is warped about 1 billion times more than space is. 1 billion? That's not a small difference. That's a giant blinking sign telling us that to really understand gravity, we need to be focusing on the flow of time. This is our first major clue.
Okay, so if gravity is all about the flow of time, where do we look for the next piece of the puzzle? Well, the answer came from the most extreme places in the cosmos, black holes. And strangely enough, it connects gravity to a field that seems to have nothing to do with it, thermodynamics, the science of heat and information.
Now, when most of us hear the word entropy, we just think disorder or messiness. But a much more powerful way to think about it is as a measure of possibility. It's really just counting all the different hidden ways you can arrange the microscopic parts of something while it still looks the same on the outside.
The classic deck of cards analogy makes this crystal clear. Think about it. There's exactly one way for a deck to be in perfect, brand new order. That's a very low entropy state. But how many ways can you shuffle that deck? A number so huge it's hard to even write down. That's high entropy. The universe doesn't prefer messiness, it's just that there are overwhelmingly more ways to be messy. It's just playing the odds.
So, what on earth does this have to do with gravity? Well, it turns out, everything. The huge breakthrough happened when scientists figured out that a black hole's information content, its entropy, wasn't stored in its 3D volume. No, it was encoded on its 2D surface area. It's like everything that ever fell in was saved on the boundary, like a giant cosmic hologram. And suddenly, there it was, the first real link between gravity, information, and thermodynamics.
And this leads to a truly mind-bending new idea called entropic gravity. In this picture, an apple falls not because it's being pulled, but because the universe as a whole has vastly more options, more freedom when the apple is on the ground. The apple is essentially being pushed by the sheer force of probability, following the path that unlocks the most possibilities for everything else. It's wild.
So that gives us a powerful why gravity might exist. The universe wants more options, but it doesn't explain the how. What's the actual engine driving this? For that, we've got to go deeper, all the way down to the quantum level, where reality itself might be getting built moment by moment.
So here's this new theory, and the best way to imagine it is to think of a quantum movie projector. You start with this raw material, a timeless ocean of pure possibility. Then every single time quantum particles interact, it's like the flash of the projector bulb. Click! It collapses all that potential into one single static frame of reality. What we experience as the smooth flow of time is just an illusion created by these frames flashing past at an unbelievable speed.
This theory gives us a new and crucial variable we can call Q. And you can think of Q as the local refresh rate of reality. Or maybe even better, it's like the pixel density of the universe in a specific region of space.
And right here, this is the core of the whole idea, and it's totally counterintuitive. It says that the flow of time, F, is inversely proportional to Q.
So in plain English, the more quantum events happening in a spot, the higher the Q is, the slower time itself actually flows there. It's like a kind of informational traffic jam. The busier reality is, the slower it moves.
So now we have all the pieces. We have the why from entropy, and we have the how from this quantum refresh rate. Let's put them together and watch how the phenomenon we call gravity just emerges.
This slide lays out the whole causal chain. Let's just walk through it. Step 1. You start with a concentration of mass and energy, like a planet. Step 2. All that mass just naturally causes a whole lot more quantum interactions to happen in that region, which leads to step 3. You get a higher Q value. Reality is basically being woven more densely right there. Now for the crucial link. Step 4. This higher Q causes time itself to slow down in that area. And finally, step 5. What we perceive as the force of gravity is just the difference in the speed of time between that slow spot and the faster space around it. So you see, mass doesn't pull anything. It just changes the local refresh rate of reality, and gravity is the consequence.
And this is how these two huge ideas merge into one single powerful story. Entropic gravity gives us the big picture why. It tells us the universe is driven toward states with more possibilities. And this dynamic disentanglement theory gives us the microscopic how. It's the specific quantum engine that slows down time to make it all happen.
Now, this is so much more than just a new theory of physics. It's a completely different way of looking at the universe. So for this last part, let's explore some of the profound implications of living in a cosmos that is constantly building itself from the ground up.
This whole journey really leads us to a radical conclusion. The smooth, continuous reality we experience every day is a kind of high-definition mirage. And underneath it all is a deeper, almost digital-like reality made of information being constructed one quantum frame at a time.
And that, of course, leads to a truly profound question. If the universe isn't some fixed stage, but is an ongoing act of creation, then what is our role in it all? Are we just along for the ride, just watching the movie unfold? Or are we somehow part of the process?
And here is where things get really speculative, but also incredibly exciting. This framework opens the door to the idea that consciousness, our focused attention, our intention, might not be a passive bystander. It's possible that we are active participants, that we can influence the local rate of reality's creation, helping to actualize what is possible. So, the ultimate takeaway is this. Gravity isn't a pull from a static past, but an emergent push into a future of greater possibility. It's the story that unfolds when the cosmos chooses freedom. We don't live in a universe that's finished or winding down. We live in one that is actively and constantly unfolding. And we are all a part of that story.